Welcome to lecture 2.2. In this lecture, we shall see about the system properties which comes under the discussion of signals and systems. In the previous lecture, we had seen how an input interacts with a system, say h of and gives an output y of t. In this lecture, we shall try to interpret how to characterize a system through some of its properties. In particular, we will be interested in knowing more about key properties that are required for characterizing a system in a disciplined manner. We shall discuss these two properties, namely linearity and shift invariance, in this lecture. So let us begin. First, we take up the notion of linearity. Linearity is composed of two properties, namely additivity and homogeneity. So let us see in detail what are these properties. First, we pick up additivity. By additivity, we mean that if I have an input signal x1 of t and another input signal x2 of t, each giving rise to an output y1 of t and y2 of t respectively, if I feed on the sum of the two inputs, which is x1 plus x2 of t, which is nothing but the pointwise sum. So let us make that clear. It is the pointwise sum of the inputs. If we give that to the system, it shall result in an output which is nothing but the pointwise sum of their outputs. This property is known as additivity. Let us discuss homogeneity. Consider a system whose input is x of t, giving rise to an output of y of t. If I scale the input by k, if the resulting output is also scaled by the same factor k, I call the system to be homogeneous. To illustrate these ideas, let us pick an example. Consider a system, say y of t equals x of t square, and let us pick up the two properties of additivity and homogeneity. To check for additivity, we need two inputs, which is x1 and x2. So we apply the sum of the inputs x1 plus x2 of t. If I feed the sum of the input, I shall get the square as the output of that system, and let me call that output to be y hat of t. If I expand the square, I shall get x1 squared plus x2 squared plus 2 times x1 x2, which is not the same as y1 plus y2. Thus, this particular system is not additive. Now, let us check for homogeneity of the system for the same system which is defined by yt equal to xt squared. So, to check for homogeneity, we scale the input by k. Our input is k x of t, which is squared to get the output y of t. Now let us expand this and see what we get. As it is clear here, this is not equal to the scaling of the output by k. Instead, here it is scaled by k squared. So the system is not homogeneous in this case. Let us now consider a second example where the system is defined as y of t is t times x of t. So I scale the input by the time t at that particular point. Again we pick up the two properties, additivity as well as homogeneity. In this case, one can easily verify that the output y of t hat is equal to t times x1 plus x2 of t, which is the same as y1 plus y2 of t. The given system is hence additive. We check for homogeneity here. Y hat of t is k times x of t times t, which is also equal to k times the output y of t. Hence, the system is also homogeneous.